Module 4, Lesson 10, Writing and Expanding Multiplication Expressions. Learning targets. I can identify parts of an expression using mathematical terms for multiplication, and I can view one or more parts of an expression as a single entity. So we are going to start by taking multiplication expressions and using the fewest number of symbols and characters. So we're going to take a long expression and make it a small one. So we're going to start with 6 times b. How could we take 6 times b and make it so it has the fewest number of symbols and characters? Well, we're going to start by taking out the multiplication sign. We don't want that. So this is now going to become 6b. And that means the exact same thing. You're still multiplying 6 times b. We just no longer have the multiplication symbol. 6 is still going to be a coefficient and a factor. And b is still going to be a variable and a factor. And lastly, we can call 6b the product. Let's do another one. So we have 4 times 3 times h. And remember that the little dots also mean multiplication. So we're still multiplying. So how can we take this expression, 4 times 3 times h, and write it so it's using the fewest numbers and symbols possible? Okay, we can start by multiplying 4 times 3. So now we have 12 times h. However, that's still not writing the expression in fewest numbers of symbols and characters. So now we're going to get rid of our multiplication sign. We don't want that. So we're going to have 12h. Okay, and that is the expression written in the fewest number of symbols and characters. This is the exact same thing as this, and it's going to give you the exact same answer. Don't believe me? Let's try it. So let's give h a number. H equals 2. So we're going to take the first equation, 4 times 3 times h, but we're going to plug in 2, okay? So 4 times 3 is 12, times 2 is 24. Let's take the new equation, the one with the fewest number of symbols and characters. So we're going to have 12h, so 12 times 2, and that equals 24. These match. They're the same. Let's do another one. So now we have 2 times 2 times 2 times a times b. So what are we going to do first? Well, we're going to get rid of all of these 2's. And 2 times 2 times 2 is 8. So now we're going to have 8 times a times b. And the last thing we're going to do is we're going to get rid of those multiplication symbols. We don't want them. So now we're going to have 8ab. All right, next one. All right, we have 5 times m times 3 times p. So the first thing we are going to do is we are going to get rid of the 5 and the 3, and we are going to make it one number. So what is 5 times 3? That is 15. So now we're going to have 15 times m times p. And we don't want those multiplication symbols. No, we don't. So goodbye. So we have 15 mp. And one last example for this way of taking an expression and making it simpler. We have 1 times g times w. So we are going to get rid of these multiplication symbols. So now we have 1 g w. However, according to the identity property of multiplying by 1, whenever you multiply a number by 1, you're going to get itself. So we don't really need the 1 because GW times 1 is going to be GW. But GW or 1GW. It's both acceptable. They're both perfectly fine answers. All right, so now we're going to take an simplified expression and we're going to expand it. So we have a simplified expression of 5G and we want to expand it. And that means we're going to have to add in a multiplication sign. And no, we're not going to be using the X. We're going to be using the dot. So this is going to become 5 dot G. So 5 times G. So that's how we expand. We're just going to go back in and we're going to add in our multiplication sign. So now we have 7ABC. Expanded, we'll have 7 times A times B times C. So now we have 12G. We're going to go in, we're going to add our little multiplication sign. So 12 times G is our expanded expression. All right, so our next one is 3H times 8. And no, we're not going to do 3 times 8 because we don't want to simplify it even more. We want to expand it. So we're going to go in and we're going to add a multiplication sign between the 3 and the H so that our expanded expression reads 3 times H times 8. And our last one is 7G times 9H. And once again, no, we're not going to be multiplying 7 and 9 together. We don't want to simplify, we want to expand. So we're going to add a multiplication sign between 7 and G and 9 and H. So we're going to have 7 times G times 9 times H. And lastly, we're going to figure out how we can find the product of these expressions that are going to be using letters and numbers when we're not given a number to substitute for the letter. So we're going to start by finding the product of 4H times 7G. And we're going to simply multiply 4 and 7 together to get 28. And then we can multiply F and G together, and that just says F and G. So our product is going to be 28FG. Let's practice with another one. So now we have 3DE times 9YZ. So we're going to start by multiplying the 3 and the 9, and we're going to get 27. And then we can multiply the DE and the YZ together, and that just stays DEYZ. So our product is going to be 27DEYZ. And let's do one more. So we're going to double the product of 6Y and 3BC. So let's start by writing our expression. So we're going to have 6Y times 3BC. And let's start there. Let's find out what our product would be just by doing 6Y times 3BC. So we're going to multiply 6 and 3 together, and we're going to get 18. And then we're going to multiply Y by BC. So that's going to say YBC. But now we have to double the product. So we're going to take this and we are going to multiply it by 2. So 18 times 2 is 36. This YBC stays exactly the same. So our final answer is going to be 36YBC. Lesson summary. An expression in expanded form. An expression that is written as sums and or differences of products whose factors are numbers, variables, or variables raised to the whole number powers is said to be an expanded form. A single number, variable, or a single product of numbers and or variables is also considered to be an expanded form. Now go complete the problem set.